All right, homework 10 is day 2 of nonlinear systems. These ones we're solving by using either the elimination method or the substitution method. The method is basically your choice. We've talked about a couple of different reasons why you might prefer to use one over the other. Substitution is always available to you. No matter what the scenario is. Elimination might be easier if, say, both equations have an x squared or both equations have a y squared. All right, so these ones, for number 1, 2, 3, like these, you potentially could use the elimination method, but there's a chance that the substitution method is going to be easier. So let's look at something like number 3. Remember, when you're doing the substitution method, the very first thing you want to do is make sure that one of the variables is by itself in one of the equations. So for number 3, the top equation, y is already by itself. So when you get yourself to that point, what you want to do is take that expression and sub it into the other equation, excuse me. So you've got this expression for y, and you're going to sub it in to that y. So it'll look like this. X plus, and then instead of y, you're going to replace y with this expression, because my top equation tells me that's exactly equivalent to y. So it's like saying, if this y is equal to this expression, why can't this y be equal to this expression? That's exactly what we're going to do, is just sub in that expression and then finish off the rest of the second equation. So this is just the second equation, except instead of a y, we subbed in this expression from the first equation. Now you should be at the point where you only have one variable. If you still have 2 variables, the substitution that you chose was not a good one. It still might have technically sort of worked, but if you still have 2 variables, the substitution you chose was not good and you should do another one. So now we're all in terms of x. Once that's the case, we can combine like terms. So the x and the 4x combine up to 5x. Here, since we've got a quadratic, you want to get everything on one side so that we can solve by factoring. So here I'm going to add 3 to both sides. And then this, since there's a 2 out front, I'm going to factor by doing slide divide. So slide the 2 over to multiply by the 3. And then we start with x times x. We are looking to multiply to 6 and add to 5. So that would be a positive 2 and a positive 3. And then make sure you finish off your factoring by finishing the slide divide, by dividing by 2 again. So 2 over 2 makes this a 1. 3 over 2 does not reduce, so I slide the 2 back over. So those are my 2 answers. Set them equal to 0. So when I take x plus 1 and set it equal to 0, I subtract 1 from both sides and I end up with -1. That's one answer. Second answer, I would start by subtracting 3, and then I would divide by 2. So subtracting 3 and then dividing by 2. That's my second answer. So I have 2 x values. The way that you finish off substitution is by subbing each of those answers back into one of the original equations. So you could sub even into this one. Like this bottom one's probably a little bit easier than worrying about subbing in and squaring and everything like that. So you could take this bottom one and you could just subtract the x, and you could have y equals -3 minus x. We might as well sub into that one. So first you have y equals -3 minus the first x value. So that comes out to be -2. So I have -1, -2 as one of my solutions. Second solution, minus -3 halves. So think of this as like a -6 halves and then plus 3 halves. So that would be a -3 halves. So it's actually just the same value repeated. So -3 halves, -3 halves. Okay, so I have 2 solutions here for number 3. Let's find one on the next page, like I was talking about with the x squared and the y squared. So a lot of these are still good candidates for substitution. Actually, the last one, this very last one, number 12, would be a good one to look at, where I would vote for elimination. So you see how they each have an x squared and a y squared. So let's take the bottom equation and multiply everything through by a -1. And then that way, the negative x squared would cancel with this positive x squared. So we're going to multiply everything by a -1 so that we can add these equations together. So when I add them, the x squareds will cancel. I have y squared minus 4y squared, which is a -3y squared. And then 13 minus 25 would be a -12. So then you can solve this for y squared. First thing you're going to do is divide both sides by that -3. So -12 divided by -3 is a +4. And then you solve a quadratic like this by taking the square root of both sides. So when you solve a quadratic by square rooting, make sure you always start with a plus or minus. And this here, the square root of 4, comes out evenly as a 2. So now you have two possible answers for y. Those values for y can get subbed into either one of the equations. The top one looks a little bit simpler, so let's go with that. So we have two different y's. So x squared plus the first value of y equals 13. So when I square this, I get 4. I can subtract the 4 from both sides, so 13 minus 4 is 9. And then I solve this quadratic by square rooting. So here I have a plus or minus for this as well. So I have a plus or minus. So I'm going to start listing off my solutions. So when I plugged in +2, I got +3 or -3. So putting them, making sure they're in the right order, I have this so far. Okay, so this +2 for y ended up pairing with two different x values. So I have two solutions so far. I can plug in the -2 as well. And what ends up happening is I actually get the exact same solutions, because the -2, when I square that, I still get a +4. So I run through these exact same steps. I subtract the 4 from both sides. I take the square root of each side, and then I once again end up with +3 or -3, but this time they're pairing with the -2 for y. So +3 pairs with the -2, -3 pairs with the -2. So I end up with every combination of +3, -3, and +2 and -2.